Yes. Yeah. I've started the recording. Yeah.
All right. Yep. Once again, thanks everyone for joining with us today. So today our agenda would be Salesforce Data Cloud for architects. Uh, so earlier in my sessions, I've been talking on Data Cloud for admin, Data Cloud for developers, and now Data Cloud for architects. I know you've been many of the architects have been attending for today's session, but today you would love to understand the complete depth of an architecture across the data cloud, and you could see multiple things. And definitely this is going to be a well worth session. Out after this you will definitely bring something out of which, and you will definitely learn something out of this today's session. If you have any questions, so feel free to reach out to me as well in LinkedIn. So welcoming to myself Phaneendra, and I'm based in Singapore. I'm a Salesforce MVP. I'm a two-time Salesforce marketing champion. I lead Singapore Salesforce marketers as well as Slack community group leader. So you can follow me on LinkedIn and with Phaneendra Arigacheta, and then you could follow me on Twitter as well with Arigacheta. So this is what my bio would be. Let's get into the agenda. So I'm not sure whoever joined in my past sessions on Data Cloud, but again today I would love to go through what is Data Cloud, and then we could talk about Data Cloud. So here I would love to huge shout out on why I kept as architectures. So in Data Cloud, I would love to specifically talk about the product architecture, and I would love to talk about the systems architecture, and then data architecture, the data flow, and I could love to talk about how the entire Data Cloud fits in Customer 360 architecture. And we could take some key takeaways from this session, especially on the benefits of Data Cloud. And then there are some resources which I've kept specially for everyone to learn about on the architecture wise. So we'll go through each and every topic which is detailed, and then you could learn something as well. Well, I'm sure that so all of you are starting your career with the Trailblazer, and we make sure that we're working with at least in your past experience with different companies, different enterprise companies, different ESMB, SMB companies. Always the biggest question where employer asking us saying that, is there any way Manish or Funny or someone, so I want to save the time to make the unified data. Um, can you free up some time for modern data unification solutions? Can you help us for building a solution, or can you help us to build an application to free up some of the resources, and then to increase or to increase to free up some tech resource cost? Can you introduce an AI for some certain applications to bring down the cost reduction? And the same question for asking us saying that, hey, can you automate some of the processes we've been involving in our day-to-day life to increase our productivity, right? So these are all some of the common fundamental questions which I've been raising day to day for every Trailblazer. Even when I'm talking to certain Trailblazers in my past and today as well. So the biggest questions where the employees have been asking us, where the companies have been asking us to do all this unified data saves time, reduce cost, and automate a couple of things. The fundamental questions, right? But we know in our daily lives we have plenty of data. With this, after COVID, I think we all got to know what is the power of data, because the online shopping experience have been increased tremendously, and then we have 100 gigabytes of data which has been hosting on the cloud by 2025 has been what the experts have been saying it. And then when you go anywhere, when you go to the shopping center, when you've done any shopping, when you purchase anything, so everything is a data, right? When you go and then book your cab, and then you go and visit your mall, and then you have to send one of the product, you would love to see the product, you want to purchase the product, so every touch point is a data, right? So you're going to see the plenty of data going on in the next couple of years as well. That's where the data you ever seen never before. In next 2 years it will be massive. But the biggest question for the enterprise standpoint is, I've been working on many enterprise companies, which the biggest question, integrations. The, the question comes up with the data. And the next question is how we could integrate the data to become a single source of truth. Is there any application that we could design a data which is sitting in different sources of systems, where we could do some ingestion and transformations, And do we have any data lakehouse where we could transform that? We could leverage any storage locations to have some historical data or the new data. Can we build some predictions as well? You ever imagine 36% of IT time is spending on designing, building, and testing custom integrations? It's a massive of data which is sitting in every company. Your volumes of data. There are systems which have been siloed. You know how integration time is most important for our vital complex integrations, and the most important thing is the maintenance cost, security and compliance, and technical expertise. You're going to bring all these factors into your designing of a data application, which is going to be massive from a point to point integration or a point to multi point integration. So you have to collect all this information, right? So when you bring companies need to deliver this personalized experience because you have data sitting in somewhere, and then you would love to bring the data, which you would love to, unify the system, and they want to use the same data for a single source of truth for different applications altogether, where they would love to use the data for personalize their experience and increase their ROI from a day-to-day perspective. You believe every company, if you look at on an average, an enterprise company has 976 different applications have been sitting in their entire company's portfolio. Every company would love to see a faster response time. Every company would love to deliver the faster response time to their customers, which increase their customer experience. 62% of customer experts companies to anticipate their needs in a way that they would love to design an integration to play a pivot role, which they would love to use the connectivity to apps, and they want to scalable their entire application, and they want to extensible to give their application to some of the third party companies to leverage for an extensible purpose. With all this, Salesforce have been introduced a powerful, one of the innovative platform that what I've seen today is Data Cloud. I've recently gone through, even today, I went to one of the event, which is Snowflake by Data Cloud. Even Snowflake team have been coming up with different innovations. They're one of the innovation today that I've seen today in their keynote would be Snowflake Data Cloud. So the Snowflake also been introducing their own data cloud. But if you look at Salesforce Data Cloud, there's a huge major differences between data clouds across all the enterprise companies, even Snowflake, Salesforce, even Microsoft, and there are other companies have been building their own data lakehouse on their own systems of enterprise. But when it comes to data cloud, our Salesforce Data Cloud, which can connect and harmonize all your customers' data at scale, and which design your unified file that makes you a lot confident, that makes you to leverage this single source of truth, and you could activate the same personalization experience across all these verticals, which is nothing but your sales cloud, service cloud, even you could bring this data back to your different systems all together to make the customer 360 with this data cloud. Because been looking at most number of sessions which I've been talking to different architects. uh, if you look at the Salesforce CVPs or the VPs of a product evangelist from a Salesforce side, so this is a massive solution which has been successfully running through a different biggest companies, different enterprise companies altogether. Everyone have the same feeling structure that so it saves more than 1.5 hours of each and every employee time on a weekly basis, which brings a potential touch points from a source systems which they could collect all the data sources, and then feed up their complete stuff, and then they're going to design the single source of truth record, which can further leverage to personalize their customer experience altogether, right? So that's what the massive of data cloud. But you would believe always, we are a customer 360 CRM solutions. We have sales cloud, we have service cloud, commerce cloud, marketing cloud, Slack, Tableau, and all the systems have been placed and have been connected, interconnected very seamlessly. If you look at our traditional data model or the traditional systems landscape from a storage perspective, if you look at in the next couple of years, currently there are 13 countries have been onboarded into hyperforts, and Singapore is one of them, and Thailand, and couple of Singapore, and the nearest country that what I can know is Indonesia. So if you look at hyperforce, is a one major advantage for our Salesforce people, because now it's been available everywhere near to our regions. Initially, we only have 4 to 5 data centers where our data will be storing in those data centers. But now, with this massive extensibility of Hyperforce architecture, our systems of applications have been sitting in China, Japan, been sitting in Russia, have been sitting in different areas because there's been hosting in AWS services. It's been readily available in near to your city as well. So that's massive, and the entire data cloud has been sitting under Hyperforce. The entire data cloud sitting in Hyperforce. That's where you don't see any downtime for designing your single source of truth record. That's where you see a quick responses from the data cloud perspective. And on top of Hyperforce, you look at your traditional R databases, the transactional data, which is our account contact opportunity. So that's what we're calling as our transactional database. So on top of which we have Einstein AI. So where we are currently have a flexibility that we could design the predictions. And if you go to your Salesforce application and you have your data sitting in accounts, contacts, opportunities, where you have an option that you could design your production builder, you could design your own predictions, which can brings out your grades and scores of each and every record of a customer. And on top of which we have the business processes which are running on a flow automation, where you could use the same traditional data that you could seamlessly connect and then design your own applications, and then serves your business process for designing your screen components, do some business processes, sending an email alerts, and you could even do a platform events, connecting external systems using your data. So that's what our traditional current native Salesforce core CRM architecture. But the biggest question, so this is our customer 360, our Lightning platform, our own Lightning CRM platform architecture. But the biggest question, where the data cloud sits in this traditional CRM platform. The data cloud sits besides your traditional transactional database. Nothing magic. Thing what we're doing is, what we have done is the same thing. Hyperforce also sitting under the data cloud, also sitting under Hyperforce. The only thing that what we are doing is the entire data cloud has been designed in Salesforce Lightning platform. Fundamentally, we are leveraging our own metadata API structure, which is sitting on Salesforce Lightning. We are using the same structured principles for designing the data cloud solution as well. On top of which, you could use your Einstein AI for bringing the data cloud models, where you could use data cloud models, data cloud segments, data cloud insights directly inside your uh, Einstein artificial intelligence productions as well. And at the same time, the same data model which you could leverage in flow automation as well. So that's where it's very, very powerful, very seamless to connect. At the same time, you could use the same data of data cloud DMOs, which are nothing but data model objects, directly into your Einstein AI production builder, directly into your own flow automation processes as well. So that's what the real time comes into the picture, where you could use the same data model of data cloud, which we design the unified customer 360 back to your sales cloud, back to your service cloud, and back to your marketing cloud and commerce cloud and whatnot. We could send this data back to any other systems as well. Well, now that's what our data cloud would love to talk about on a minimal basis. And now you understand, hopefully, you understand what is data cloud and how it fits with our traditional database, right? Now let's go and talk about the product architecture. So this is something very interesting, and everyone would love to put some effort and keen to understand on this architecture. It's very simple, nothing magic as well. I'm sure that you are looking this picture for many times for different presentations, or different speakers have been talking about it, right? So the product architecture, which brings a different elements here. If you look at data sources perspective, first party data, second party data, we have our own out of the box connectors. So if you look at this, we have our own out of the box connectors. I'll just highlight this. Yeah. So if you look at your the data sources that what we have here: Sales Cloud, Service Cloud, Commerce Cloud, Loyalty Cloud. The out of the box connectors, we have the ready-made connectors that what we are currently available for Data Cloud. And along with this, we have some of the cloud storage connectors, where S3, Google Storage, the Google Cloud connectors. And then we do have a ready-made APIs, SDKs available for connecting the websites, mobile apps, which you could bring the data into Data Cloud using batch and streaming APIs. And we do have a fantastic MuleSoft connector, the ingestion connector, where you could leverage the Data Cloud connector to connect any MuleSoft third-party applications back to Data Cloud. So it's a massive, because you see here, like you see 7 to 8 connectors, but when it comes to MuleSoft, where you have availability that you could connect your POS systems or on-prem, and you could connect your third-party, on-prem applications via Mule, and then you could, send the data to Data Cloud through a Mule Data Cloud connector. And then once you've been collected all this data, which you could perform a different kind of ingestions. You have batch ingestions, and we have a streaming and real-time ingestion. And when you're connecting these data sources, currently in Data Cloud, it's not a real time actually. It is a near real time, where you have a batch ingestion kind of a concepts, which at least take 1 hour, a minimum 1 hour, to bring the data or to reflect the changes of the data from a different sources of systems. And from a mobile and websites, we have streaming real-time ingestion, which is a real-time. Uh, you can just design the SDK, leveraging the SDKs, and then you could leverage APIs to bring the data from different websites and mobile apps to a Data Cloud using streaming real-time ingestion. So once you connect those sources, you have a flexibility that you could create your data types and transformations, which are nothing but your data streams. You could design your own data streams. You could design your complete object modeling, and then you could define your data source objects, your data lake objects, your data model objects, that we could talk about in the next slide, how the data structure works, especially. And you have a concept of data spaces, where you could bring the data from different sources as well. And once you collect the data, once you prepare your data, then now it's a concept of harmonizing your data. So that's where the real-time customer graph works, which are nothing but, so we use our identity resolutions, we use our identity resolution rule sets, we use our fuzzy rules, we use our matching rules to define what is our rules to make the customer unified. We could harmonize those rules, and then finally we could design our single source of truth required. We could use our unified customer profile data using match and reconciliation rules, and we could use this data to design the calculated insights. We could design the predictions. We could use the same data for analytics, and we could just activate the same data to actions, which are nothing but you could use the data to your marketing cloud journeys. You could send the data back to your Google ad queries, the Google ad systems, and you could use the same data for inflows and journeys. And you could export the data using SQL, REST APIs, and whatnot. And you could activate these journeys back to your B2C commerce cloud, AWS, Google. So it's just bringing the powerful data from a real-time unified customer profiles to back to the own systems, because you brought the data from different data sources, and the system has a flexibility to send the activation data, the unified data, back to the same sources as well. So that's what the entire product architecture look like. So this is how the product architecture look like. Now we'll talk about our storage layer. So everyone has wanted to see how the data cloud under the hood, which works in a storage layer. As I've said, so data cloud using a Salesforce metadata, no surprises at all. If you look at data cloud, if you look at data cloud interface, it exactly shows the Lightning platform. It completely is designed with a Lightning platform, and which are leveraging the metadata concepts. Salesforce core platform, our own native core platform, which has metadata, the packaging concept, the extensibility concept, our user experience, our dev experience, our learning platform, our ISV experience. So it's all sitting under Salesforce core platform. So what we are using is we are just leveraging the backend services for computations, for scaling our services, for scaling our application to manage our cost controls. We are just leveraging the CDP backend data services, which are our ingestion, segmentation, activations, real-time profile. So all these we are using as a backend data services. So that's what I would love to bring the slide to put some what exactly has been designed for, if people really want to confuse, is a data cloud is a separate product altogether? No, it is just something that we already built on top of our Lightning platform. We're just leveraging our backend data services. That's it. So when it comes to the storage layering, so this is very important. It's very interesting as well. I know few people have been architects your entire career altogether, and still you've been working on different AWS services. The bread and butter of complete Salesforce Data Cloud is sitting, the backend services have been sitting in AWS. We'll talk about more in the next things. So from a bottom to top approach or top to bottom approach, I would love to talk about how the entire storage layer, which supports in Data Cloud, and which supports metadata at every storage level. The number one, the new data source integrated. So the number one you see here, right, when we open the Data Cloud, so you see different data sources which have been integrated using Sales Cloud, Service Cloud, or where you're going to connect your Sales Cloud, Service Cloud, Loyalty Cloud, or AWS, or Google Data Storage, or any other connectors. So when you would love to use new data source integrated, so what essentially a data cloud leveraging is a Trino or Apache Spark are the two main engines who have been working on the big data services. Because the services that what we are leveraging for integration with data cloud would be from a source system perspective, Spark, hyper integrated with Lake Library. So this is what the big data services have been leveraging from a data source integration perspective. From our data frames, so there's always a concept here, bring your own data lakehouse, right? So that's what we're going to bring always. So we use our lake library, the library which comes with the table abstraction. We use a Spark data frame and tuples for designing your complete data frame. And from a semantics and related tables, we use the cloud tables. As I said, we use a Salesforce metadata while we're designing our own tables. And the relationship that what we have, the same concept that what we're using in the cloud tables for designing the complete stores. So the most important thing, iceberg. This is a massive that what we've been investing on data cloud perspective. So the iceberg is the one which every company, I mean, not only Salesforce, but in Snowflake or any other companies where they use an iceberg concept for a table abstraction updates. Because iceberg is a concept where every data cloud solution has been designing to access your data externally from other applications. Because there are two kind of a concepts in iceberg, one with managed and unmanaged kind of concept. So the managed iceberg concept is something that your data sitting in external systems where you have to use some computation services to bring the data from iceberg to your data cloud solution. But there is unmanaged kind of an iceberg concept where you don't require any other authentication. It is just a zero copy data policy where you could bring your data back immediately from iceberg to your data cloud. So that's the main, and that is where the key for systems, because now people wanted to go with the zero copy data policy architecture. If you want to bring the data from Snowflake to data cloud, so it's completely a zero copy data policy. That's where iceberg plays a huge and crucial role for you to design abstractions and any updates also. It's a zero copy data because the data will go and sit with a template in iceberg where you can go and then extract the template, extract the data immediately or directly from your Snowflake with the real time. That's where it's a massive. And again, the most important thing that we are using from a storage concept is Parquet. Parquet is one of the column storage principle, and it's one of the fantastic concept that what's been introduced in the Parquet. Parquet is very kind of a relational database which comes with a warehouse style columnar access, which gives you the recently I've been working on one of the project where it's a concept of bringing 80 million records from a system to data cloud. So that's where we're using Parquet column storage. So it's very fast, massive in a fraction of minutes or something. So we will get the data from the third party, and then now I understand what is a massive scale behind this entire architecture or the storage, which is nothing but the Parquet, because your entire data has been storing in a columnar storage format, which you could bring down the complete warehouse style. That gives a massive information for us to speed up our data processing as well. So that's what our entire storage layer concept has been designed for, supporting metadata from each and every storage level. So let's go to the next, especially on the technical capabilities. So as an architect, you should understand what is a data cloud technical capability. But I'll take a pass and then I'll see if anyone has any questions. So let me. Okay, I think no questions it seems. So let me know if anyone has any questions. I'm happy to help you out. But I'll move ahead. So now, so far you understand what is data cloud, and you understand data cloud core architecture, which is nothing but the product architecture. And then you understand the storage layer, the storage architecture, how the data cloud storage architecture look like. And then now let's talk about the technical capability of data cloud. So this is what something I've told earlier. The entire backend services of data cloud has been storing under AWS. We are heavily using AWS services. We have a strong partnership with AWS, and this complete technical capability map that's talk about the each and every product mix involving in single platform which supports each and every system here. So if you look at the technical capabilities, we have been involving data lakehouse, where we are storing the data, big data processing, where our engines have been running to process our data, connectors, where we are connecting transformations and modeling for how we're gonna data transformations works in data cloud, and how are we designing the real-time single source of truth, and and then we could go a step-by-step process. Talking from left hand side, our storage, the file storage, our hard store, metadata store. So if you look at our file storage, we use always AWS S3 location, and along with S3, so we use our Amazon, we use our DynamoDB for storing of our entire data cloud, the storage. All our data streams and everything has been storing under these S3 locations and DynamoDB. And from a metadata store, from a SQL perspective or cache memory or security perspective, we use our Amazon RDS, which is one of the best at what I've been working on for long term. RDS is one of the fantastic and fantastic database which supports for multiple storage levels. That's what it occupies for the data lakehouse. But when it comes to the big data engines, the big data processing especially, so they use a big data concepts on this, because you have plenty of trillions of record, and millions of millions of records have been flowing into your data cloud. We need a strong heavy lifting foundation that has to be done. So our team, the product team, has been designed in such a way that it should be very strong, and it should be more seamless to connect with different big data engines. So ideally, we're using this Amazon EMR. So this is one of the powerful tool in Amazon systems, where we use Spark, Trino, Hyper, Airflows to support our big data engines for running your EMR. And we use our data flow, nothing but our Kubernetes, container Kubernetes, for working on entire big data engine. And along with this, we use our Imagine EMR systems, which you can bring together all these big data engines for data processing, and especially the connectors. When you connect CRM connectors, marketing cloud, third party, or data direct access connectors, we use our data sync, Amazon data sync application for connecting all these connectors. And along with, we use again Elastic Container Kubernetes for processing your entire data from your connectors to your big data engine. From a transformation perspective, so we use our data streams, data model entities, even data. All this data transformation was being again leveraging heavily on the Kubernetes, Elastic Kubernetes, for processing of single real-time single source of truth. The identity resolutions, your segmentations, your activations, your query services, everything has been running on your Amazon Elastic Cache, along with user Amazon SQS, which is nothing but simple queue service. Because every CDP processing where we use, at least it takes some time for us, at least an hour or 30 minutes to run the data, because it has to go and then cross all these transformations, big data engines and storage levels, and then it has to process your identity resolutions, your segmentations, activations, because these are all like a batch kind of a jobs. So it'll take some time for getting the best results out of which. So for working on a big engines or the big processing operations, we always use simple queue service, because you requested to run one of your rule. At the same time, the other company person requested your rule. So uh, Data Cloud uses simple queue service to pile up the number of requests, and then they process your request using your Amazon Elastic Cache, and then they use a Kubernetes service to run your complete engines using Spark Trino, and finally it will go back to your hard store and then bring the necessary results to your GUID interface. So that's what the real capabilities of technicalities involving in data cloud. So the most important factor here, the Lightning platform. So that's what I've said. So the entire thing has been hosting on Lightning platform. Your setup, your data cloud setup, your metadata, your apps, been sitting completely on Lightning platform. So all this has been running out on top of your Lightning platform, which is nothing but a simple backend services. So from a data visualization analytics perspective, so you have Tableau Datarama. So we have a connectors to connect your Tableau Datarama to bring all your processing data to the data visualization and analysis purpose. And you do have your activation channels, which are nothing but you could use the data, which you could send back to Marketing Cloud for messaging journeys, and you could use the same data for advertising platforms like FB, Google, LinkedIn, and you could use the same data for your own native Salesforce platform to design your own predictions to support the customers or the sales service reps for defining next best actions and next best offers as well. So that's what this entire technical capability involving in Data Cloud. So let's go to the next slide. So this now you could understand the platform architecture. So now you see the entire architecture of the platform architecture. Now we talk about product architecture, storage architecture, and we talked about our core architecture. Now let's talk about the real architecture of Data Cloud, where it defines and segregated what are all elements, what are all the building components involving in each and every area. From a top to bottom here, I would love to talk about top to bottom kind of an architecture. So Lightning based apps, which are nothing but our own Lightning core platform, which have involved metadata or core. Your application, you could design your own applications, your Lightning app platform, and you could install some of the Exchange apps designed by other third-party consultants, where you could install in directly in your Lightning app platform. From a connectors and ingestion perspective, you have Marketing Cloud, CRM connector, third-party connectors. And from a data processing perspective, you have identity resolution, segmentations, real-time profiles, query services, Einstein predictions, activations. From a transformation perspective, you have EDL transformation, data streams, data models, event data entities. And from a big data processing, Spark, Presto, and Airflow are three main components for processing of your data. And from a storage, you have your cache metadata, which is completely work with security principles. You have SQL metadata store, file storage, hard store, and from a control management plane. So when some of the enterprise companies wanted to bring their complete CI/CD kind of a concept, so yes, still Data Cloud supports your CI/CD control management plane. You have an option that you could monitor, alert, and DevOps. You could design your fantastic flows on top of Data Cloud, which you could alert how many data flows have been designed, how many data streams have been running on, any error happening in data streams, any error happening between your data transformation process, an admin will get an alert. You could design your flow to call some of your data model objects, some of your segmentation objects to build some of the flows to alert your internal teams. And from a visualization perspective, we have Tableau and Datarama, which you could leverage visualization from an activations, messaging journeys, advertising, RTM, real-time information models. So these are all the complete architecture which can work with Data Cloud. But the biggest question, so with this, because these are all something which you see functionally as an architect, but from a technical standpoint, this is something, the services which are running in the backend. So from a connectors, you see Amazon EMR, Elastic Kubernetes, and from a CDP processing, data cloud processing, what are all the systems have been involving from a architecture perspective, AWS systems, from a data transformations, what are we leveraging, and for big data processing, storage and activation channels, and control and management pipeline, control and management plane. So if you look at segregating from a functional to your systems, your technical systems, I mean, what are the services have been involving in each and every stage, that makes a massive kind of a thing. And you believe you never see all these things right in the backend. We only see the grid, we only see the grid application, we only see the setup, we only see the beautiful interface which is designing Lightning platform, but we never know what's happening in the backend. What is the heavy lifting has been done by AWS services to make our lives is very easy. So this is what the holistic architecture that I've been involving for each and every services from an AWS standpoint. Yeah. So let's talk about my favorite Data Cloud data flow architecture. So this is something that's really interesting. I really like the most of the part. Uh, from a from an architecture standpoint, this is really really important. You need to understand how the data has been segregated, and you need to understand how the data transformations is going to be happening inside the Data Cloud. Fundamentally, data is logically organizing as a three parts in Data Cloud. One, data source objects. The data source object is the one when the first time when you create a new data stream, when you're connecting your data connector like sales service, when you bring the data into data cloud, that's your sales data source objects. It always comes with underscore DSO. The data source objects are the original data sources, ideally, the original data format, which supports your JSON, CSV, and Parquet files. And these are all your built-in connectors where you could use this data to bring. And with the data sources, it has multi-source cloud storage, and it has supports MuleSoft, Kafka, and schema preserving. It has a virtual bring your own lake tables as well. So number one, the initial step, we have data stored in data source objects. After that, the raw data, what we're calling as raw data, this data will be going to be transformed. So from here, DSO to DLO, you want to design your mapping. When you click on new data stream, you connect your data, you connect your connector, the source connector. Once you connect and run your data source, you have an option that you can go and then model your object, data model, which is nothing but you can just map from data source to data lake. It's completely transformation into a schema format, and this data lake, which has been storing under iceberg tables. This is where we're talking about. Your entire data lake has been storing under on the format of iceberg tables, and it has complete hydrated by transformations concept, which are profile data, engagement data, which you could categorize and which you could materialize as well, and your Salesforce data coming directly into your data lake objects. That's one of the fantastic feature, because you have your own system which is sitting under your iceberg tables. It's very fast, which you could connect and then transform the data. Once the data has been coming into data lake objects, then you could go and then design your data model objects. You have to do a mapping between your DLO to DMO. So you have a concept where you could review mapping and then map the model. That is where you have to design your data model object. So this is where a complete canonical information model has been designed as per the best in industry standards, which are CIM model. You could just simply curate the data to power business applications. This is where I'm more concerned about, because this is the heart of your data cloud. Your entire data has been storing under data model objects, the final object, where you have to use this data model object for your identity resolutions, your segmentations, and activations. So this is what the flow when it comes to your medallion architecture from a data transformation perspective. First data source, next data lake, and after the data model. So this is what the concept of data model, which is sitting in data model architecture in Salesforce Data Cloud. So it comes to your, especially the actions. I would love to talk about, so you have mobile data, you have mobile SDK, you have web SDK, you have personalization platform or streaming data, which is sitting under different source of systems. So we'd love to talk about this kind of a data, because when we talk about connectors, now when we talk about the mobile, web, and personalization data, so these four systems, especially where you have a concept to leverage your streaming data or a streaming insights, because this, if you want to connect these systems, you always have to leverage either any one of your real-time streaming API or a batch streaming API. So you got to bring this data using those SDKs and APIs to data cloud, and then you could just transform the data, and you could apply some action rules, and you could do some enrichment of data with this kind of information. And at the same time, you could leverage data actions. Data actions is one of the concepts in data cloud, which you could the end product, by using this engagement data, you could design your unified record, and with that unified record, the single source of truth records, single source of truth data, you could send this data back to different systems, where you could send an email, a real-time email from data cloud. You don't require any other systems. You just leverage data actions, which are completely works with your platform events, because you could leverage flows and you could invoke data actions inside the flows using platform events, and then you could send an email real time. This is the complete real time. You could send an email through data cloud, you could send a charter post, you could send a mobile notification, you could send desktop notification, you could Slack a message, you could log custom to platform event. So all these things can be done in real time using data actions. That's the powerful of streaming data and streaming ingestions. So I personally like this kind of concept, because this is where the customer gets a real value from a system standpoint, from a data cloud standpoint as well. It's a event-based architecture that I would love to talk about. Complete event-based architecture, which have been evolving in data cloud. Now, let's talk about our data flow architecture. So you always believe that, so wait, the batch ingestion, this is the batch ingestion, which are nothing but your sales, service, loyalty, Amazon connectors connecting with batch ingestion. from other API web mobile engagement connecting streaming ingestion. So all these two, of course, we use big data Spark engines, which we're going to connect. And then so we use the data change actions for you have an option that you could leverage webhooks to call your data from data cloud if you have so much skill set to design your own webhooks. And from inside segmentation activation, we use again Apache Spark engines to connect to Lakehouse and then get the near real-time storage activations. And then you could use the same data to connect with different analytics and exploration platforms as well. So this is a simple data flow architecture from a source to your destination, nothing but designing your connecting your source systems and then enrich your data and then bring the data back to Einstein Analytics or W Analytics. Sorry, currently we don't have any connector for Einstein, which is CRMA Analytics, but we do have only Tableau for now. So that's what the team is pushing for. So that's the concept of data flow architecture. Now let's talk about the biggest thing that everybody aware of it. How the data cloud in C360, which is customer 360 architecture. As I've told initially, so where the data cloud sits in our native customer 360 native cloud. So on top of Hyperforce infrastructure, so we have a data cloud sitting, and then we could use other native platforms to connect data cloud data, and then you could design your own system of record. If you look at what else we can do in customer 360, which is nothing but native sales cloud, right? So we have plenty of options that we could bring the data cloud data model. We could bring the data cloud data directly into your Lightning platform. When you purchase data cloud, so data cloud by default supports by default sends you a couple of lightning profile components. So data cloud can install some of your own app builder component, like your own profile component, your own interaction engagement component, and all this stuff. Although you have an option that you could design your Lightning web components, and then you could connect. You could use one of your connect API where you could bring the data from data cloud, and then you could just design those. And at the same time, you have an option that you could use the platform events in flows. You could just invoke the flow and then invoke your platform event to bring the data on a real time, and you could send some notifications to your internal sales service teams. And the most important thing, you could build your own KPIs using native Salesforce reports dashboards, because the data cloud data model objects which are supporting natively, where you could design your own Salesforce reports and dashboards. And the most important factor, the security. From a security standpoint, all the sharing settings, OWD, and other areas where entire data model, segmentations, activations, all identity insights, all these data model related topics available for sharing settings. Because someone comes saying that, different country people are working on it, and I want to be restrict some of my data streams, some of my data sets. Yes, you do have the concept. You could use your sharing settings to minimize those kind of people not to access some of their data streams, some of their data sets. So that's all some of an admin concepts where still a platform can support data cloud for a platform events, for Apex. You could leverage Apex. You could do permissioning, security standpoint. So it all will be natively available in Salesforce. So from a platform perspective, as I've told, so we have our out of the box data cloud components. So as I said, if you look at the right hand side, so this is a diagram where you could drag and drop some of the Lightning components, which is nothing but an activity history and calculated insights, where you could use this own components, which is given by Salesforce directly within the package. You could just drag and drop to your customer 360 record, where automatically these insights will come from data cloud. And if we are really good at development, where you could create a custom cloud components, which are nothing but your own custom data cloud components using LWC concept, and then you could just bring the data, and then you could just show the data into your customer 360 profile as well. Yeah. And what I heard, Salesforce now has been going to be supporting native insights. You could use the data cloud data to Salesforce through out of the box data W. You could use a W connector, and you could use some of the CRM analytics components as well. From CRM analytics components, yet to come. But for Tableau, yes, we do have a direct connector to bring the data into Tableau in a fraction of seconds. So that's the power of our platform supports from a Salesforce standpoint. So we came to the end, almost like an hour now, and we'll see what all the benefits of data cloud. I know everybody asking a big question. So what benefits does data cloud brings into the table? Well, number one thing is from a security standpoint. And from a privacy compliance standpoint, it's deeply integrated with privacy controls of HIPAA, GDPR, CCPA, SOC 2, and ISO compliance, which has deep security controls. Trust me, there's deep security controls have been designed for some of the security controls in Data Cloud, which are massive, and still we are designing those solutions as well. From a trust and availability perspective, it's completely highly available and all the time. It's completely sitting on Hyperforce, which is purely a real-time availability. And as I said, the system is open extensible, which you can integrate seamlessly with different mesh patterns, skills. You could use iceberg concepts to connect external systems, and you could bring your own warehouse, bring your own lake, bring your own models. You could design your webhooks to connect the Salesforce data cloud to bring the data from your third party. It has multimodal data platform which unifies the storage to support different analytics platforms, machine learning, application building, query rich transformations. So all this thing can be done inside Data Cloud, and it supports metadata, our own native cloud, and it has complete lot of people working on Exchange components to an open ISP friendly ecosystem. You could design your identity components, connectors, and you could deploy it to Exchange. And coming to the scalability and the system storage perspective, it can scale to petabytes of data. Petabytes. It's more than zettabytes, petabytes. It's public cloud scale using AWS infrastructure, and it has a high velocity of ingestion modeling and the transformation modeling, and completely works with the native lakehouse pattern, which is nothing but your real-time lakehouse activation platforms with events and changes, with using streaming APIs, streaming events, platform events, and it has batch patterns. And of course, this is low code, pro code, no code kind of a code. It's completely a declarative platform which clicks not code. So these are some of benefits of Data Cloud. And if you wanted to start something today, let's start something, and then you could see a potential value of this product, which could bring a massive personalization experience for every touch point on this customer base. And still, this product is fantastic, and I would personally request everyone to go and learn something out of which. And a couple of resources I would love to shout out. So if you want, you could download some of the technical availability from here. And if you would love to explore more diagrams, please go through architect.salesforce.com, and then you could see all those diagrams, different diagrams available on our template gallery. And if you want to connect with Salesforce architects, you could go to the websites, Twitter and LinkedIn, and you could just post your questions, and then people will definitely going to answer all your questions on Data Cloud. And you could use your official Trailblazer community groups where you could post the questions, and the evangelist will go and then help you out for every question on architecture side. So the closing words, what I would love to talk about, as we know, like as a customer, as a customer's most trusted technical resource. So we as an architect needs to truly understand how our products work. So how our products really works, and and how the Salesforce Data Cloud that continuously to learn more about some existing technologies, and then especially as they need to bring together with the different data source to get a complete view of the customer becomes even more critical, even more critical to the fuel of AI capabilities. So just go and then leverage some of the Data Cloud resources that what we've been recommended. On top of which, I would wanted everyone to take a look about what is Apache Iceberg, Parquet database, data actions, and just go and then learn some. Just go and then grab some template gallery in architect.salesforce.com website. You could see potential plenty of things which you could see under template gallery. So that's a good start for everyone to build some architecture for your customers as well. So there are some resources which I would love to give away. So this is one of our Data Cloud bootcamp that we have run for the last couple of months, and this has been completed. And if anyone wanted to see something on Data Cloud, wanted to learn Data Cloud on a step by step, so this is one of the resources where you could learn complete stuff. So that's all, team. Thank you, Manish, for giving us the opportunity to talk on the architect side on the Data Cloud. And definitely we're gonna see you on Dreamforce if anyone traveling, or we could see you on some other sessions. Thank you.
Thanks, Fanny. A lot of information I know for everyone. A lot to digest, I would say. Uh, but good insights, fine. I think generally this side of this, the architecture side, we don't get to see. Mostly the sessions cover the features and what we can do from the front end side. Yeah, but thanks for covering the back end side as of it as well from my architecture point of view. So
Thanks,
I'll,
Manish. Thanks, everyone. Any questions? So I'll happy to.
So I think there's just one question. Any other databases behind the scenes except for the ones from AWS?
No, nothing. No, no. Only a complete AWS databases we are using. We're using RDS. We're using uh, S3, and we're using some Airflow. So those things. That's it. We're not using any other databases.
Okay. And the data, once it is transformed, right? Once we have the unified view of a customer, so the same, so using the same connectors, the data flows back to the source system, is it? Or we have to do
Exactly.
other?
Yes, yes, Manish. So all the unified data again goes back to the same data storage, because once you purchase your data clouds, you have your own storage space, because you're going to purchasing the storage space. That's what your credits are. So
Hmm.
would love to call one thing here. Data cloud now comes with a credit kind of concept, pay as you go model in AWS, like the same model they're introducing now. So you can purchase your own credits. Once you start your data cloud, package, you have a separate dedicated S3 stage, S3 location. You have a separated dedicated S3 buckets available. So all your data sits in your S3 buckets and all the stuff. And as I said, if you're really expert in webhooks, designing webhooks and everything, so you could directly connect your webhooks to your one of the data cloud endpoint, which is given your setup, where you could connect your endpoint and then bring the relevant data as well.
Hmm. Okay.
So if you look at tenant, if you look at setup, everyone. So when you click on setups, you have a concept of data cloud endpoint, where we're calling as data cloud tenant secret key or a tenant secret ID. That's most important for every API user that would love to integrate with data cloud. That is most important, because that is where your entire AWS infrastructure has been hosting in. So it is very, very important. So don't share that key with anyone. If you want to share that key with anyone, of course, on top of key, there are some more authentications required to access the data cloud data when you want to build some webhooks. But that key is very important. Don't share it with anyone. Yeah, that's one of the things.
Okay.
Any other questions?
Looks like none. But just one other question on the transformation. Can we
Yes.
also encrypt and decrypt methods are available like for the data transformation, especially with PI data? Some clients might ask that we want to encrypt the data.
It's a good question, Manish. So I personally haven't gone through that PIL data cloud encryption.
Mm.
I've been working on native cloud encryptions and all using Shield and other products. But from a data cloud standpoint, because this is the data which has been motion the entire data is completely motioning and sitting on AWS services. Because your complete data which has been encrypted in AWS services, because they have the security keys and everything which is encrypted. But if you look at Manish, in the data explorer, when you go on and query, you can see the data of a customer. Like,
Mm.
if you query data model object that what you design for unified individual object, so it'll automatically pull the data directly into your data cloud UI, which contain first name, last name, email, phone number, and all. But from an encryption standpoint, not sure whether it supports encryption or not. But I have to check it out. Yeah, I think this is one of the last question that have been in the mind. I
Yeah.
keep checking it. Yeah, I have to.
Okay. Thanks, Funny, for your time and for the session. Thanks a lot.
Thanks, Manish. Thanks everyone for joining.
Thanks a lot for joining. Yeah.
See you. Bye bye.
Bye. See you all in the next sessions. Yeah.
See you.